Olá, muito bom dia a todos. Sejam bem-vindos a esta primeira sessão técnica da Qt Con Brasil 2020, a nossa edição online. Meu nome é Sandro Andrade, eu serei o coordenador dessa sessão. Então, sejam todos muito bem-vindos mais uma vez. As sessões técnicas da Qt Con Brasil, elas terão uma duração total de 45 minutos, no máximo. Então, nós teremos apresentações de 30 minutos, seguidas de mais 10 a 15 minutos de perguntas. Então, estamos todos aqui acompanhando pelo YouTube. Eu gostaria de solicitar que vocês deixassem que as perguntas fossem enviadas após a apresentação. Caso contrário, fica mais difícil nós acompanharmos aqui o histórico do YouTube. Ok? Então, vamos passar aqui para o inglês e apresentar o nosso convidado de hoje. All right, welcome again, everybody. I hope you are all fine and safe. Yes, so welcome for this very first technical session for Qt Con Brasil 2020. And we are honored to have here one of the Qt company team's engineer with us. The Qt company has been a quite important and faithful partner of Qt Con Brasil since its inception in 2017. They are always very kind and helpful in helping us in several aspects to build this conference, and we indeed appreciate that. And today we are happy in having Corey Pendleton joining us for this session. He's talking from Kansas, I think.
Yes,
and,
that's right.
Yes. So, Corey, thank you very much for being here with us. And Corey is currently a senior pre-sales engineer at the Qt company. He's been working with software engineering for the past 14 years, 7 of those using the Qt framework, which led him to work at the Qt company. There he enjoys sharing the amazing work they are doing to keep Qt at the forefront of user interface and application development across platform and form factors. And so without any further ado, and Corey, thanks for being here once more. The mic is yours.
Thank you very much, Sandra. Hola a todos. It's a great honor for me and a pleasure to speak with you guys today. And thank you very much for having me. And we're here today to talk about the future. So what does the future hold? We all like to know which programming languages will become dominant, which companies will make the next technological breakthrough, and what is the next revolutionary user interface beyond the touchscreen. And how can we prepare for that future? So today we're going to peer into the crystal ball to envision the future and how the Qt framework fits into it. As Sandro said, my name is Corey Pendleton. It's a great pleasure to be with you. I've had 15 years of experience in software development and automation and consumer devices. I've had 7 of those years working with the Qt framework with my focus on front-end user interfaces. And now as a solutions engineer with the Qt company, I enjoy supporting our customers, sharing the wonderful things the Qt framework can offer, sharing the development workflow as we envision it, and most recently engaging with the Qt for Microcontrollers product and developing demonstrations and things along those lines. And it's amazing to see all of the different ways that Qt is being used by our customers around the world to really create remarkable user interfaces. So to envision the future, I feel like we have to look back and learn from the past. You know, as Jose shared a few moments ago, 25 years ago in 1995, the first version of Qt was released. And over the lifespan of Qt, we've seen the rise of the desktop computer, personal computer. We've seen the rise of the Linux platform. We've seen the decline and return of the Apple computer. And after 10 years of growth, we stabilized our API with Qt 4 for 9 years of binary and backwards compatibility. And this was a great feat for our team. And over the lifespan of Qt 4, we saw the introduction of mobile applications, touch screens, smartphones, right? And as Qt 5 entered the market, Qt was in a position where we had to pivot to expand and to grow into these markets. And with Qt 5, we stepped into the embedded space in a big way. And for 11 years, we've had backwards compatibility and binary compatibility across the lifespan of the Qt 5 product. It'll be 11 combined years by the time the 5.15 version ends life. And so the Qt framework has always had this focus on how can we create a solid framework with solid foundations that can be relied on by developers for years to come. And yet we need to look to the future, and we need to be prepared, and we need to move the framework into that future. So where do we see UI and application development going? As Jose shared, we really see this in embedded, and we've been there, and we see it coming in the future. Powerful, beautiful graphics, dynamic user interfaces, but on low-cost hardware. And at the same time, as this pandemic has shown, we really can't ignore the desktop because there's a lot of value for all of our customers in working with desktop applications now that we're working remotely, working from home. So it's important that we not ignore our strengths as we move into the future. So where do we go next? And how do we foresee the world of Qt development in the next 10 years? Design. Design is what sets an application apart, or a device, the user interface. It makes it a pleasure and a delight to use, or it can be an annoyance. And Qt is positioned to enable world-class design through tools like our Design Studio. We'll talk a little more here about that. With Design Studio 1.6, we have bridges that import designs from common designer tools like Photoshop and Sketch. We have a visual 2D and 3D editor that allows you to combine two-dimensional and three-dimensional objects into your user interface in a seamless way. We have a flow editor now that was recently introduced that allows you to design prototypes and build out an actual UI flow from page to page with a graphical tool. Timeline-based animations with keyframe curve editing. It's a powerful way to introduce transitions and animations and state management into your application. And with Design Studio 1.6 and 1.5 even, we've unified the graphical tooling between 2D and 3D. So there's no more separation between the 3D studio that we've had in the past and the Design Studio for 2D. They're now both combined into one feature-rich tool in Design Studio. Another new offering has been the Qt Marketplace. So the Qt Marketplace is a central rallying point for the Qt ecosystem. You are creating amazing extensions to the Qt framework every day. You may be creating them internally, you may be creating them and realizing these can be used by others. And so the marketplace is a place where you can publish your work, you can sell it even. It enables collaboration with the development community at large. We currently have over 100 extensions that are available today from partners and developers just like you around the world. In addition, you can purchase live training courses directly from the Qt company and our partners. And there's other things that you can purchase through that marketplace. And as we move forward, as of Qt Creator 4.12, we've integrated this directly into Qt Creator, where you can search the extensions that are available. You can find tutorials as well. And we're working to streamline the delivery and installation process even more in the coming year. And so released in December of last year, Qt took the next bold step into embedded development, a new class of cross-platform development with Qt for microcontrollers. They're tiny, with a tiny footprint. Hello World's under 300K. That's fast. It takes advantage of the acceleration software and 2D acceleration that these microcontrollers are offering, and it's easy to develop with the common familiar Qt Quick API that can still be compiled down to run in such a small footprint. Here's one of the demos that is one of my favorites that we have today, and I'll run this video. And as you can see, the total RAM usage for this very graphically intensive application is 11.2 megabytes. It's 11.2 megabytes. The Qt framework as a whole, when you run on an embedded device, you're talking around 100 megabytes minimum for all of the, and usually more than that, depending on how many of the modules you need for all of the modules. But the Qt for microcontrollers offering can get down into these kinds of spaces and still create a dynamic and fluid user interface. So what's the latest? Where are we going? Where are we now as kind of this first step to the next? Qt 5.15 is kind of setting the stage for Qt 6. It's the final release in the Qt 5 family, and it's an LTS release, so it's going to be supported for the next 3 years for our commercial customers. And it paves the way for Qt 6. We were able to take more time to identify the changes that were going to be needed and to flag those in 5.15 so that developers could be more prepared for a port and a transition into Qt 6 to make life a lot easier than it may have been in the past. So Qt 5.15 brings in the first vision of our new graphics architecture. It's optional in 5.15, but it'll be the default in Qt 6. And it gives us independence from OpenGL by taking advantage of Vulkan and Metal on those appropriate platforms. And we'll be moving in with Direct3D as well. And you'll still have OpenGL as an option, as an abstraction for the backend, as well as software rendering. It extends Qt Quick with 3D capability. And we unified the 2D and 3D graphics pipelines so that there's less issues with synchronization between the two as you combine your user interfaces. At a high level, the architecture and the workflow works as you can see here. You can import your assets from design tools like Blender and Maya for 3D content, Photoshop and Sketch for 2D content. And we're bringing in more bridges as well with Figma and Adobe XD to really make it as easy as possible to bring your UIs directly out of design tools into actual functional code. So then Design Studio can turn that into actual QML source code and graphical assets that get compiled and run on the device. So we call it the Qt Rendering Hardware Interface, and it's an abstraction for 3D graphics APIs. It's an internal API that's tuned towards our specific Qt framework use case. It abstracts the graphical objects that are used across these different acceleration frameworks, so materials, meshes, and shaders. It integrates with our platform abstraction layer and provides a cross-platform shaders using the Qt Shader Tools module. You can see there some of the graphics APIs that we'll support. But basically, we want to ensure that Qt runs and uses the first class graphics acceleration framework for the platform that you're running on. So as the world has moved into remote work, there's been a massive growth in virtual spaces, augmented reality, and other 3D interactions. And Qt Quick 3D has positioned us in a place where we can develop applications for these spaces. It's a spatial renderer for Qt Quick. It uses the existing functionality of Qt Quick, no parallel implementation as it was with 3D Studio, but it's a unified architecture, one scene graph, unified 2D and 3D graphics. And this creates an efficient application, better performance, no duplicated resources, even no need for frame buffer objects in many cases. Qt 3D is built on QML. All the QML language features are available. Animations are so easy to do, and you're manipulating a full 3D scene. It combines with the existing APIs, and we really focused on making it easy to use. And so for me as a developer with years of 2D experience, coming in and seeing a 3D object in my user interface and being able to manipulate that using APIs that I'm already familiar with and see things like camera motion and lighting effects change dynamically, it was amazing just to experience. New features in 3D are post-processing effects, improved support for 2D UIs inside a 3D scene, spotlight type support. We support 4 different types of dynamic 3D lighting now within the Qt scene graph. So you can manipulate those programmatically in your application. And so we see this as increasingly important in the future. Why? Because we see more and more interaction with 2D content in the 3D virtual spaces. And Qt 3D really positions Qt as a key development framework, not just for touchscreens on desktops, but for worlds of virtual reality and augmented reality. So where are we at with Qt? We've made improvements to the QML language, and these are setting the stage for even further improvements as we move into Qt 6. So required properties enable you to define APIs within your QML components that are more clear to the users, what must be applied in order for this component to function properly. Inline components are more efficient than previous methods of declaring components. Nullish coalescing is just a developer ease of use benefit. I wish I'd had this for the last 7 years. I'm excited about that. And then there have been various other improvements, right? In particular, Qt Multimedia has brought in support for rendering the multiple surfaces. Qt Lottie is fully supported now, which is After Effects animations that have been generated in After Effects that can be rendered inside Qt applications now. And so all of this sets the stage for Qt 6. Where are we going next? Qt 5 was released in 2012, and somewhat in a rush to pivot into the mobile space and the embedded space and kind of establish Qt as a viable framework in these developing areas and developing kind of technological verticals markets. After 7 years, it's time to take a look back at what we've done and try to identify a way to set a foundation for the future so that we can build the next generation. Re-architect our core where it's required. So at its core, Qt value, these are some of Qt's kind of key values, right? Cross-platform, that's a must. That's what we're all about. Being scalable, running your UI across different levels of hardware, different power of processors, GPU, no GPU, etc. World-class tools that are easy to use, intuitive APIs, and then maintainability, stability, and compatibility. That matters to a developer. How easy will I be able to maintain my code? How stable will these APIs be? And compatibility across different platforms and compatibility across different versions. From very low-end hardware to high-end systems, Qt 6 needs to be able to adjust our product to new market demands while keeping these values at the heart of what we're doing. So speaking first to compatibility, our goal is to allow compiling most applications against both 5.15 and 6 with minimal workarounds. And so that will enable you to support customers who may be on older platforms that are not supported by Qt 6, while at the same time preparing customers who are able to move forward for the new. House cleaning. It's great to clean up some of the deprecated functionality and just the cruft that we all understand builds up over years of development. So we're able to remove all of the deprecated functionality, and it creates a smaller default installation, which is a better experience, right? You don't have to download as many gigabytes, right, of data to get all the Qt libraries that you need. CMake will be the build system for Qt 6. And Qmake will still be supported. It's been a great tool, and obviously many of our customers are using it because it was our first class build tool. But CMake is by far the most widely used build system in the C++ world. And so for us to integrate better with CMake just makes sense. And on top of that, it frees up our development team to focus on what matters, which is the core of the framework and the new features and what's coming down the road, rather than developing on a build system, right? So Qmake will continue to be supported. It's not going anywhere, but all development in the future will be focused around CMake and expanding support for CMake. And kind of finally in our foundations, we're going to require C++ 17 as kind of the base standard for Qt 6. When 5 was released, we were on C++ 98, and we later were able to move to C++ 11 around the 5.6 release timeframe. And it's just that time to keep the framework modern, to be able to take advantage of more readable code, structured bindings, and init statements in ifs, etc. All of the benefits that C++ 17 is bringing us. We want to be able to use those as we establish and build out the framework. And so these are some of the foundational decisions to set the stage for the next generation of Qt application development. So for the next few minutes, I'm going to walk through a few of the technical details, and then we'll kind of summarize that and talk about how we see that involved in the future of Qt development. So we're rethinking our containers in Qt 6. The main thing is we want to close the gaps between the STL and Qt containers so that there's less duplication. The code structure and syntax is more familiar to developers. It makes it easier to understand and adopt for new developers. But we'll still maintain our Qt APIs. We're unifying QList and QVector, right? There has been a lot of discussion about this on the development listserv, and rightfully so. QList has been around forever. It had some performance issues. QVector has always been a better performer, but it had its own kind of issues, and retrofitting was a challenge. So I think we've settled on kind of the best of both worlds, where we're going to unify to one class. QVector is an alias to QList, but it'll enable all of the existing code to continue to compile. We're going to work to get rid of the performance issues that QList had. So this improves performance in almost all cases, and the source compatibility is almost 100%. So it hopefully makes the transition easier, but it simplifies the API, right? I knew about QList long before I knew about QVector, and when I discovered QVector and the benefits, I was a little frustrated that I hadn't known about it earlier to know when to use it. Well, now it doesn't matter so much. There's one API. Developers won't be surprised or confused by that. There's a new QHash, has better algorithms, significantly lower memory usage, and better performance improvements. We've got Unicode strings throughout. Some may be cheering at this, but no more QString literal, no more QLatin1 string or string ref. You'll be able to use just string literals in quotes in your code, and we just assume the Unicode UTF-8 source code format. QMetatype and QVariant have, in Qt 5, they've had some issues. We've had one handler per shared library, chain handler structs, separate handling of user types that led to separate code paths when you're dealing with user versus built-in types. And so in Qt 6, what we want to do is get rid of handlers in QVariant. We're using pointer to QMetatype as an ID in QVariant, generating these structures for QMetatype at compile time, the same handler for both. And it greatly simplifies handling of the metatypes and improves performance. And that leads to improvements to the meta-object compiler in QMetaObject, which has made the meta-object system directly usable within QML. This has a ton of performance and just general interoperation benefits between QML and C++. You can gain type information within QML. More can be done at compile time rather than having to do as much property flags determined at runtime, right? So less iteration over the chain of meta objects. There's just a ton of benefits that we can bring to QML because of that. And then we're bringing some of the best parts of QML back to C++. I'm super excited about this, the new property system in C++. We will basically use the template system to declare your properties. You can see here it's an easy to use API. It's real property based. You don't have to write the pseudo getter setter functions anymore. It's built in so that values can be updated and returned, just as you may have seen in QML, and this will be available now throughout the C++ portions of the framework. Lazy binding, evaluation, you look at the performance numbers there. It's like an order of magnitude better than it was in the old system. So it's a fantastic addition to our C++ side. And then solving some of the current issues that we have with QML with a high memory overhead, object model being separate from the Qt object model. QML has thus far required a full JavaScript engine with garbage collector. There's performance overhead. Binding propagation was synchronous and immediate, right? Not synchronized with the scene graph. It could lead to dropped frames. And duplicated binding evaluations. You get property thrashing. Language issues with weakly typed QML. We had issues with maintaining and integrating with C++. The versioning was inconsistent between, which Qt module do I import for 5.15 and which QML module should I bring in. And we didn't have a way to do really good encapsulation, so just kind of a core object-oriented principle. So moving forward, we've introduced strong typing. And we have support for compiling QML to efficient C++ and native code because of the new property system, right, that's built into C++ now. JavaScript becomes optional. You can choose whether you need it or not. And if you can avoid it, then it creates a better performing and more separated UI and backend logic. We've removed the need for versioning when you import your QML modules, and we support hiding of implementation details, encapsulation within the QML language. So further changes to the graphics stack, as I mentioned, all of QtQuick will use the 2D, both 2D and 3D will use the rendering hardware interface. OpenGL will just be one among several graphical backends that you can choose. We'll have full support for Direct 3D, Metal, and Vulkan. Shaders that will be cross-compiled so that your shader effects will work on all of the different GPU frameworks. And then we're moving the OpenGL classes out of Qt GUI, so that'll modularize and shrink the size of Qt GUI, and you'll have OpenGL classes in a separate module, Qt OpenGL, if needed. With QtQuick controls, we're adding some new styling and theming. So this will give a native look and feel on all platforms, all the desktop platforms. It'll be easy to customize. And this is something we've always wanted to do since QtQuick Controls 1. And with the performance issues that we identified, we moved to QtQuick Controls 2, which is now the QtQuick Controls. And we never really were able to bring that theming in for desktops the way we wanted to. We left it kind of with a focus on mobile and embedded development. Well, moving forward into Qt 6, and this won't all be done for 6.0, but it'll be coming into 6.1 as we go. But moving forward, we'll be bringing in that desktop look and feel, because remember, we see now that desktop applications are not going anywhere. They're important, and we knew that. But soon you'll be able to use QtQuick to develop those desktop look and feel rather than having to rely on Qt widgets, which has been around for a while. And we'll continue to support widgets. It's not going anywhere, but all of our future work is going to be focused down the QtQuick path and making it kind of the preferred framework for developing applications, even on desktop platforms in the future. One thing I wanted to highlight too is the C++ APIs. We're working towards a public C++ API for QtQuick items and controls. And that's just another way that we can enable the use of the Qt Quick framework from within C++, so that those who are more confident and comfortable with widgets will not have as much of a leap to take advantage of the Qt Quick APIs. So yes, this is the first step in a journey. It's a reduced feature set in Qt 6. All of the focus has been on the essentials, which, as it should be, we want the foundation and the essentials to be solid. And then as we move forward, Qt Quick 3D is supported, and most other modules will then get ported in later with 6.1. And 6.2 will be our first long-term supported release. So that's our goal for complete feature parity and platform parity will be with Qt 6.2, which will come later in 2021. But with 6.0, there'll be a reduced set of platforms at the release. All the desktop and mobile platforms will be supported. Embedded Linux will be supported, but some of the other embedded real-time operating systems will follow on just a little bit later, within a release or so within 6.1. So. And so, our timeline, we've had our platform and structure freeze in June. We had our feature freeze in August as planned, which is great. Our first beta will be released here in the middle of October, and that's on track with our final release being set before the end of the year. So where does this leave us? What's the future hold for Qt? Well, as we see it, the future is with embedded devices. We're expanding into the MCU space. It's with native GPU acceleration with the rendering hardware interface. And it's with improved design, through the Design Studio tools, Qt Quick and Qt Quick 3D. We believe that these are the tools and the foundations that we need to build upon to enable Qt to create the next generation of user interfaces and really establish our slogan, our motto that the future is written with Qt. So with that, I wanted to mention, as you may already be aware, October 22nd, we have our Qt World Summit. It's a virtual summit, of course, this year and free to join. So I encourage you to go to the link on the screen here and sign up. You can come and find more details and deep dives into some of these technical elements of what you may be interested in for your projects and your applications. And with that, Sandro, I think we're ready if there are any questions for me today.
Yes, thank you very much, Corey, for the nice presentation. And in particular, I've been following all the Qt 6 snapshots you've been released, and I can testify that's a great work coming. And yes,
We've done a lot of work to prepare ahead of time, so that it's not as much of a shock when you do the transition from 5 to 6.
Yes, I guess now we can move to the Q&A part of this session. Yeah, I'm keeping an eye on our YouTube chat. So there is a question from Silas. Is there any news for the Qt Widgets module?
Qt Widgets is going to continue to be supported, and we'll do security fixes as needed within the libraries that it depends on. But there's not a lot of new development going on with Qt Widgets. Again, it's not going anywhere, but our focus is going to be on Qt Quick because it really enables taking advantage of the GPU and those are almost always available these days. So we want to encourage development in that direction.
Great. And we have another question from Lucas. Is there any shader support for Qt Quick 3D?
There is shader support. 3D is a higher level than I personally deal in for the most part. So I know a bit of the concepts of OpenGL and 3D, but I know that shaders are going to be supported. The material, textures and meshes and models, all of those sorts of things are are obviously part. You got to have that for 3D. But I think that incorporating shader effects and things like that are going to be part of Qt Quick 3D as well.
Awesome. So we have a couple more questions. So I will ask it twice in one turn. From Eduardo, is Qt 6 available for free or only in commercial licenses? And from Mateus, any forecast on when Qt will support C++ 20 features?
Great questions. Okay, so the commercial question, no, Qt 6 will remain available to the community as open source. Our long-term supported releases have moved to commercial only because commercial customers are really the where that kind of stability is a key value. But Qt 6 will continue the tradition of open source. We're not leaving that behind by any stretch. And then regarding the second question, that was about C++ 20. It's certainly on our minds. Obviously, we want to establish Qt on a foundation that has some history, and so we can't always cut to C++ 20 in 2020, but we want to give the development community at large time to absorb and incorporate those principles into their experience. And then undoubtedly we will move to C++ 20 at some point in the next few years during the lifespan of the Qt 6 product. But no specific timeline for you now.
Great. Another question from Romario. I get the feeling that for new desktop applications, the way to go is Qt Quick from now on. Would there be any reason to create a new application with Qt widgets instead?
Sure, there is. One kind of highlighted by Eduardo is if you're developing for a customer or a target that may not have support for C++ 17 yet. Maybe the compiler isn't there for that, for an older platform. It may make sense to use widgets. And again, as I mentioned, the desktop look and feel isn't there yet. It's coming in 6.1-ish for Qt Quick. So you still have a little bit of time where that's going to be, if you need that desktop, platform-specific look and feel, widgets will still be kind of your ideal go-to. But yeah, I think you're right. In the future, the way that we see the future moving is going to be towards Qt Quick as the primary framework.
Yes, so while we have no further questions from the YouTube chat, I have one from myself, if I may. One of the features of Qt 6 I've been really looking forward and excited about is actually to get rid of all those QString literals things in our source code, right? And when trying the latest snapshots, I've seen a lot of places where we can actually get rid of QString literal, but not yet when constructing new QStrings. And I saw a discussion in the Bugreports website saying that it would require a lot of changes in QString API. So for Qt 6, will we be able to create a new QString without the QString literal stuff?
You got me. This is one I'm not sure on, where we're at on that. So that's something that I can find out for you and get back to you on. But no, I don't know specifically on what the internals are there, just because I haven't had a chance to dive into that source yet. So I'm not sure what the issues are that are leading to that. Obviously, I think that we recognize that it's an issue. And so it's one of our priorities to fix. It's one of the reasons why we highlight it in our future kind of vision. And so I anticipate it will eventually be done, but it may be one of those things that's kind of the next step on the journey while we're at the first step, right?
Great, thank you. One question from Eduardo: when is Qt 6b available to be downloaded?
Yeah, so the beta, as I said, will be out in October. And so at that point, you should be able to pull the source. It'll be tagged. Of course, it's available in the current form, which is early alpha stage on the Git repository. But the beta should be available, and then the final version will be probably, we're still scheduled for the 1st of December, but my gut tells me it'll probably be the second week or so of December at this point.
Awesome. And let's check for more questions on our YouTube chat. Agostinho has a question. He says that he's been using Qt over the past 15 years to teach object-oriented programming, and he's asking where he can, what he can do to increase the chance for new Qt professionals in the market, right? How to spread Qt in the market?
Yeah, that's a great question. We are very interested in trying to get support for Qt into educational institutions. And it's kind of an upcoming kind of focus for us within the Qt company and our marketing. And so, obviously, Qt is open source, so it's available for students to make use of. Now, with the source code being available, sometimes compiling and getting things set up can be a bit of a headache. So that's something we want to support and enable. We're beginning to do some outreach with various universities and colleges to try to offer that to their computer science groups. And so I would say that if you have some specific cases where you think that would be useful or interesting, and if you feel like the lack of binary availability is a challenge, then I would encourage you to reach out to the Qt company, and we can work together with you to provide, kind of like an educational type of use case, so that you can provide some binaries for your use within that space. But as I said, it's kind of a new thing that we recognize the benefit and we want to get in there, and we're just kind of starting to establish those paths.
Thanks, Corey. I think we have time for one or two more questions. There is one from Mateus. Will QList behave the same way as standard vector performance-wise?
Yes. So, part of what they're doing with QList, I believe, this is a bit from memory, so don't hold me to it, but the performance improvements that I mentioned with QList, part of it is trying to do some of the same sorts of pre-allocation to the end of the QList as you would have had for QVector, because common operation even within QList is we're using it as an array, but as a list to append data to. So I believe the intent is that we'll have some of the same benefits that you would have gotten from QVector in QList now. And that's kind of the goal by unifying those things.
Great, so let's go over the last question from Saulo. Will Qt 6 provide any new features regarding smart pointers?
Regarding smart pointers, I'm not aware of any specific additions. We have the Q shared pointer, we have Q scoped pointer today, and those will continue to be around to provide that smart pointer kind of behavior. So I don't think that we're adding very much in that regard. But one of the things that I like to do whenever I'm interested in something like that is go out to bugreports.qt.io and do a search for the type that you're interested in, smart pointer or one of those types, Q shared pointer, Q scoped pointer. And you can see some of both the bugs as well as new feature kind of user stories that describe some of the new features that we're looking at doing and tags in there on when they'll be brought in. So that might be a good use case. But yeah, I don't think there's any plans for anything in particular in that regard.
All right. With that, we come to the end of the of this quite fruitful and interesting session. So, Corey, thank you once more for being here with us. We appreciate it.
Sandro, muito obrigado a todos.
Great, awesome. É isso, pessoal. Obrigado pela participação de todos. Nós retornamos às 14 horas com a próxima palestra da Qt Con Brasil 2020. Um abraço a todos. Bye, bye.